Hello and welcome to another nostalgic ramble. Today we are looking at the department's paper 1 from November 2022, question 2.2. Let's see. So, if the sum from p is equal to 0 up until p equal to k of a third times p plus a sixth is equal to 20 and a sixth, determine the value of k. Okay, a whole lot of fractions going on, but also not really much going on. So the first thing you want to do with questions like this is to expand the sigma notation bit. So you do that by just replacing p with the whole numbers 0, 1, 2, 3, up until k, whatever k is. So that'll be a third times 0 plus a sixth plus a third times 1 plus a sixth plus a third times 2 plus a sixth. And then so it goes until we have a third times k plus a sixth. And we are being told that that is equal to 20 and a sixth. Okay, so now the next thing I'm going to do is I'm still going to, treat these as a couple, and evaluate what each term comes to, what each term in the series comes to. So the first one is just going to be a sixth. The next one will be a third plus a sixth, which is a half. The next one will be 2/3 plus a sixth, which is 5/6. And so it goes until we have a third times k plus a sixth, which I'm just going to keep like that for now. So let's see what's going on here. I suspect it's probably an arithmetic series. So to go from a sixth to a half, we are adding a third. To go from a half to 5/6, we are adding a third again. So it is within reason that this is an arithmetic series. If you need a bit more convincing, you could add a few more terms here, right? So a third times 3 plus a sixth is 1 and a sixth, which is 7/6. Right, and to go from 5/6 to 7/6, you're adding 2/6, which is the same as a third, right? So it is giving arithmetic series. So it is an arithmetic series where the first term is a sixth. The common difference is a third. The number of terms in the series, and this is, I was about to say it's k, but we need to be careful. We always need to think about where did we start counting, right? So if we had started counting at p is equal to 1, and we were counting up until p is equal to k, then yes, that would be k terms, right? So it's like if you're counting from 1 until 5, you count 5 numbers. But if you start counting at 0, that adds an additional term, right? So if you count from 0 to 2, you're going to have 0, 1, 2, 3 numbers. If you count from 0 to 5, you're going to have 6 numbers. So this is actually then going to be k plus 1 terms in total, right? And we are curious, and we're told, that the sum of these terms is 20 and a sixth. So we can use this information to set up another equation, right? Using our knowledge of arithmetic series, we know that the formula is Sn is equal to, what is the formula? N over 2 times 2a plus n minus 1d, right? So we can use that to set up our equation. So Sn is equal to n over 2 times 2a plus n minus 1 times d. Right, so I've just substituted all that information into this equation. And again, just a whole bunch of fractions nothing to fear, right? Just going to simplify inside, so this becomes a third. K plus 1 minus 1 is just k, and times a third, which is just k plus 1 over 2. And then here, we could even factor out a third, right? So this could become common factor of a third, and then we're left with 1 plus k, right? Simplify that a bit. So that's going to be k plus 1 times 1 times 1 plus k, which is the same as k plus 1, right? At the top and at the bottom, we'll just have 2 times 3. Okay, and I'm going to write this as an improper fraction so that we can do some cross multiplying. So that will be 121 over 6 is equal to k plus 1 squared over 6. So we actually don't even need to do any cross multiplying because these are the same. That means these must be the same. So we now have 121 is equal to k plus 1 squared. Then we can square root both sides, but remember, we must always consider both the positive root and the negative root, and use the context to decide whether both are relevant or if only one solution is relevant. So here we've got k plus 1 is equal to 11, or k plus 1 is equal to negative 11. So k is either equal to 10 or k is equal to negative 12. But what is k, right? K is, first of all, greater than 0, right? Because we can't count, we don't use sigma to count backwards, we only count upwards. But secondly, k also represents, well, k plus 1 represents the number of terms in the series. So that can't be a negative number. So in fact, we could have disqualified it here already. We could have said, well, k plus 1 is the number of terms in the series, and we can't have negative 11 terms. But even here, we can still then disqualify, right? But k is greater than 0. I guess could be equal to 0 if we were just counting one term in the series. But either way, it's not negative, is the moral of the story. So this is then the solution. K is equal to 10. Let's see what the memo thinks of our efforts. Right. Yes, so we agree that k is equal to 10. 10. Okay. Right. Thanks for tuning in, and yeah, you know, you're free to leave comments, ask questions, ask for clarification, show a different approach. All of that is welcome here. Cool. See you another time for another video.